afternoon, everyone. Today we are excited to present our project on scalable machine learning model for detecting suspicious transaction. Fraud is a growing concern in financial transaction, and traditional methods are struggling to keep up. Through this project, we aim to build a more efficient fraud detection model using machine learning. Now I am introducing our project. Financial fraud is a major issue with millions of dollars lost every year due to fraudulent transaction. As online payment increases, fraudsters continuously evolve the techniques, make it difficult to detect suspicious transaction. Traditional fraud detection relies on rule-based systems which are often too ineffective against sophisticated fraud patterns. Now I am going to present problem statement. The main challenge in fraud detection include high false positives, classes imbalance, and evolving fraud patterns. Most models either miss fraudulent cases or wrongly classify, legitimate transaction as fraud. We need a robust, scalable, and real-time fraud detection model that minimizes these issues. Now I am going to present existing solutions and their drawbacks. Many companies use static role-based detection systems. This model lacks adaptability and results in high false positives. Machine learning offers a better accuracy but still struggles with imbalanced data and computational efficiency. This is where our hybrid model comes in. To solve these challenges, we developed a hybrid model combining XGBoost and Random Forest. Now my teammates will explain our proposed solution and model we used.
Objective: to develop an accurate fraud detection model, to enhance transaction patterns, to use supervised and unsupervised learning technologies, to ensure scalability and real-time processing, to evaluate and optimize model performance, to develop an API for development. Proposed solutions: model selection and training. Implemented a hybrid fraud detection system combining rule-based machine learning and deep learning approach to improve accuracy and efficiency. Utilize pre-trained machine learning models, example random forest, isolation forest, autoencoders, LSTM, train on large transaction dataset to detect fraud detections. Proposed solutions: fraud prevention mechanism, dynamic thresholding. Unlike fixed rule-based systems, dynamically adjust fraud detection threshold based on evaluation models. Explainable AI, enhance transparency in fraud detection and ensuring fair decision making. Applications: banking and finance, e-commerce and payments, cybersecurity.
Dataset and data processing. We used the credit card fraud detection from Kaggle, which contains 284,807 transitions. The key challenges was class imbalance, as fraud cases were only 0.17% of total data. To address this, we applied smoke to balance the dataset.
Models that we used: logistic regression, random forest classifier, decision tree classifier, XGBoost classifier. Hybrid model: we combine XGBoost and random forest for getting highest accuracy. This is our proposed model. XGBoost: high predictive power and strong handling of imbalanced data. Random forest: add stabilizations and reduce variance by combining multiple trees.
Flowchart. This diagram of our model knows data processing, cleaning, scaling, and balance the dataset. Future selections. Identifying importance. Future using XGBoost and Random Forest. Model training XGBoost and Random Forest. Separation. Hybrid model integration. Combining both models using weighted averaging. Evaluation and comparison. Testing against other models. Result and performance comparison. Our hybrid model outperformed individual models. Here are the key matrices. Accuracy 99.93%. Precision 77.27%. Recall 86.73%. F1 score 81.73%. The result confirmed that our hybrid approaches detects fraud more efficiently while minimizing false positive. Now my teammates will discuss how we will deploy our models and its real world application. So I am here to explain the deployment on Hugging Face. To make our model accessible, we deployed it on Hugging Face spaces using Radio. This allows users to input transaction details and receive real-time fraud detection results. The deployment steps are: train and save the model in the pickle format, build an API using Flask or Fast API, integrate a user interface using Radio, and also host it on Hugging Face spaces for real-time fraud detection. And the real world applications are: our fraud detection model can be used in different and various industries, bank and finance, detecting unauthorized transactions in real time, e-commerce and payment gateways, preventing fraudulent purchases, cryptocurrency securities, in identifying suspicious blockchain transactions, insurance and loan fraud detection, in identifying fraudulent claims and applications. So in the conclusion, I'm here to summarize our hybrid model successfully enhances fraud detection by improving accuracy and recall, reducing false positives, enabling real-time fraud detection through cloud deployment. Our future enhancements in our project is implementing deep learning, for example, LSTMs, graph neural networks, for better fraud pattern detection, developing self-learning fraud models using reinforcement learning, deploying on cloud platforms such as AWS Cloud, Google Cloud for scalability. Thank you.